Welcome to Form Labs, Form2 SLA 3D Printing 101. This is the checkout, the one take for safety checkout. So we are going to go through today how to use the Form Labs 2 here at Circuit Launch and with MechLab. So basically, what I want to start off with is like, what is SLA and what are some of these things? So the first thing is I like SLA's stereolithography apparatus. That's what the SLA stands for. Also known as resin printing. It's a form of 3D printing using your models and layer by layer creating photopolymerization, which is basically the UV light inside the printer causes the chains of molecules to solidify, and those sort of create the polymers, and the polymers then create the body of a three-dimensional solid. That's basically how resin and SLA printing works. And there are three main types of 3D printing out there. So you have FDM, which is your basic 3D printer. It's like a glue gun with a piece of filament of plastic that goes through and it prints all of the layers. Those are your standard consumer printers and ones that we have in there. And the SLA, of course, is the resin printing. SLS is a little bit different of a process. It is a process where you take powdered nylon usually, and it sprinkles a fine layer, and then a laser comes in and solidifies that layer, and then more sprinkle of powder comes down and another layer, the laser hits, and another layer, and it builds layer by layer up that way. So those are the three different types of 3D printing technology that are commonly used. There are others, but they're all based kind of on that basic format. So what we're going to do is just talk a little bit about what are the differences of them. So FDM, for example, it's very low resolution. It's quick, dirty, it's cheap, it's fast. You have, it's got a lot of issues to it, but it's a very great first print 3D print. SLA, on the other hand, the resolution is beautiful. That's actually the nicest. Like, you get really fine details. It's perfect for you're about to go to manufacture for a part that you're going to get injection molded, and you need to do a fit test that has a very high resolution, precise model, so you can feel exactly what the tolerances are. SLA is perfect for that. SLS is a little bit lower on the resolution, not by much, but it does have the surface finish, which you can see it has a grainy feel because of the powder and the way that it's done. So very, very strong though, very, very strong, where the SLA has the best surface finish, the best resolution, and the best accuracy out of all three of these different types of printing. Granted, this chart was made by Formlabs, and so they are going to benefit the stereolithography apparatus model of that. Throughput, pretty much the resin printer will take an hour minimum, no matter how small it is, just to get your part to bind to the actual build platform. So if you have a very small part where FDM might do it in like 20 minutes or 10 minutes or something like that, it'll still take an hour. However, as your parts get bigger, depending on how it is, you can sometimes get faster on SLA versus the FDM, and vice versa. SLS is actually, I think, a little faster than all of them. It's actually a very, very fast process. Complex designs. The SLS is the best for complex design. The main reason is because of support. Selective laser sintering with the powder, and the way it does is that powder is the support, so you don't have to model. The program doesn't have to like put in different things. It just holds everything, and then when you're done, you take your part out and dump out all the powder, and then recover the powder. But you can make very complex parts that you don't have to worry about support. You don't have to worry about orientation. It just does it. SLA, on the other hand, Formlabs, the reason we use the Formlabs printer, not another SLA printer, is because the software is really good. The software will help you a lot. And in fact, because the software is so good, we have like a 95% success rate with prints on the SLA, where FDM, even if you had great software, there's still a lot of issues, and the best people I've seen in general use get a little bit better over than 85% of their prints come out. They fail for sometimes no reason at all. Something goes wrong. There's lots of reasons why your prints fail in FDM, and an FDM can actually be although it says ease of use, I discount that immensely. Yes, it is accessible, but I would not say that 3D printing, in FDM is easy. Yeah, there's a lot of stuff that goes on. So some of the pros and cons. The FDM is fast, low cost consumer machines. You get it for a couple $100 these days, super cheap. Materials are like $30 or $20 a reel for a ton of printing. SLA, on the other hand, it's a great value. Of course, that's what Formlabs says. We charge about 40 cents a milliliter at the time of this video for you to use our resin. You can purchase your own resin and tank together and use it on our machines for no cost to you from us. But the resin itself and the cleanup and all of this stuff, it does cost money, and it's not inexpensive. It is cheaper than getting your part printed in SLA somewhere else, which is really, and of course you can get it done very quickly from us. It's very high accuracy, smooth surface finish, lots of functional applications. SLS, super strong functional parts. That's one of the design freedom. Like you can just design anything and it prints. And there's no need for the support structure. The surface finish is not that great. It doesn't take to like finishing with like paint and other stuff very well. And it's expensive because we don't have an SLS machine here at the time of this video, and so you do have to get it printed by someone else. But it can be very, very good. The cons for FDM, low accuracy, low details, limited design capability. You're always trying to figure out which direction you need to put it in, where support needs to go, and it can be really challenging. Where SLA, the build volume is a lot smaller on the Form2. And also UV light is a problem. Like if you put it outside or a long time UV light, it just gets more and more fragile as you go on. But there are lots of different types of resins that you can buy. They're strong and tough finish, all sorts of things. SLS, rough surface finish, like I said. Limited material options. Really, it's just a form of nylon is all you get. So those are kind of the different ones. Lots of other things that are going on with materials. We only allow PLA on our FDM. You can buy your own sorts of crazy amount of resins, from biocompatible to flexible, tough, castable, dental, medical, thermosetting plastics. Like I guess that's the type of resin. But like there are just tons. And the castable resin is really cool. They even do draft resin if you want to do faster prints. The SLS, again, really just engineering thermoplastics, nylons. Training, we'll go over that. The rest of it doesn't really matter. So let's go ahead. I'm going to pull over a video into the screen and talk a little bit about the process of actually what is going on in in the actual resin printer. And so this is basically, we're going to start this video from, it's a 3D rendering of what the printer does and what it is. And it shows that a little UV laser. And so I'm going to play and probably talk over this about what it's going on. So you can see it goes through, but the important part is you notice that it is going through the bottom of the tank. The bottom of the tank is transparent, and that laser goes through. That affects the tank. It does cloud it over time, and the tank does tend to be a consumable. That's why when we charge for resin, if you actually do the cost out, we have to replace our tanks every couple to 2 to 4 tanks, or rather cartridges of resin. So those become a consumable as much as the resin, and that's built into our pricing. But the laser goes through and it hits the bottom of your part or the build platform, which has squeezed a layer of resin, and that solidifies it. And that is how it creates it. So you can see it actually right there in a real image of what it's doing. Now, notice this part right here. what it just did is the tank moves left and right. So this is the tank. The cartridge is what's technically the thing that has resin in it. But this tank, as soon as it does one layer, the tank moves to peel the part off of the tank. Then it lifts up, and then the wiper goes back and forth to clear any surface stuff. And then it pushes back down and then continues the next layer. This is the main reason why this is slow. It is the mechanical action of after every layer, the tank moves, the build platform lifts, the wiper moves across, and that's what happens. And that's how it builds its process. And you can see some really, really cool things. So understanding this process is important for your success of prints, because you have to understand how it builds so that you can design and set up your part. So, and notice it all attaches to this build platform right up here. The tank will automatically fill as it goes through, but also the resin also flows around. Like you can see it moves a little bit. And then now there's the useless part of the video that we're going to quit out of. So that's basically how it prints. And kind of important for you to understand that process so that we can create good prints. So let's start next on tolerances, constraints, and printing methodology. So the orientation for self-support, because it creates an upside down print. I don't think I have any of my prints. Oh, I do. I have a little print right here on my desk of a little octopus with wearing some VR goggles and stuff. So the part of we have to think about is how is this going to be, my model going to be oriented so that it has the most success for self-support. Because it prints from the build platform downwards, upside down, you have to worry about the weight, of course, because if you get something with a tiny little stem and then a big full thing of resin, it's too much strength, and you're going to have to deal with that with the supports, or like too much weight, and it could pop itself off. The other part is that if I imagine a tree upside down, as long as all of the branches are going, starting from a trunk and going this way, it will print really well, as long as it's branching out from big to smaller to smaller to smaller. The moment you have something that goes like this, that goes through different layers, what you do is you create parts that would be called minima, where as that little loop comes up and comes back in, sometimes you have parts that aren't supported by the other part. Like it's starting to print something that exists here, but it doesn't connect until further down in the print. Those need to be supported, otherwise they just float away, and that doesn't help. So when you're thinking about orientation and it's self-supporting, it's usually meaning that there are no parts of your model that kind of connect to the rest of the model later in the print rather than earlier in the print. Of course, support is what you do to solve this, but just like FDM, you want to avoid as much support as you can. Like you want to do as little support as you can always, because it gets a better surface finish and less resin and all sorts of other things like that. So that's the idea with orientation for self-support. So I'm going to click on right here. Let's see and then pull up this form. Let's see if this actually was correct. And my link. Okay, design specifications for 3D models in the Form 2. So there are some things, this link, which we'll put in there, creates, like here are kind of the specs that you need to think about. So they have minimum supported wall thickness. Supported meaning, of course, that the edges of the walls are held together. Can be as small as 0.4 millimeters. Minimum unsupported wall thickness, the same. It doesn't really matter. We'll talk about something of how that interacts with printing later. There are things like unsupported overhangs, which is only 3 millimeters. So overhangs can be a bit of a problem, but unsupported overhang angle, meaning just how much can that, like if the build platform is on this bottom part, how much of an angle can this be at, there, and it's 19 degrees from here to here. I think we often talk about like the 45-degree angle on the FDM being that magic number of there. And so that being a little bit more. So there's some cool stuff that this can happen, but all the specs are on this website. And we can talk a lot more about any of those as you go along. But a couple of the other ones, minimum clearance. It should be at least a 0.5 millimeter. I've found in practice that it needs to be a little bit more than that. I think in general, it's better to have a minimum of 1 millimeter or more for clearance, because if there's any clouding on the tank, when it builds these parts, they will like fuse together. And so they won't actually be distinct parts. So you may want to be careful of that. Minimum hole diameter. Now, so this is what I want to talk about: holes, drainage, and air holes. So with your parts, if you have a cavity in there in your part, which you will probably want to make your parts hollow to save resin, you need that resin to be able to come out and drain out. And so they recommend it to be 3.5 millimeters as a minimum for drain hole. That allows that viscous resin to drain. Of course, you may also need to think about like the fact that if there's no other air in there, that can be a problem. Like it may not come out as easily, but you'd be able to get isopropyl in and at least wash out the resin, and it could come out. So in general, they recommend the drain hole be at least 3.5 millimeters to be able to get the resin out of a cavity. We'll talk about cupping in a minute, which happens when you have that situation too. But actually, let's talk about it now, because minimum hole diameter for air is smaller. It needs to be 0.8 millimeters. I'd recommend a millimeter at least. And the reason you'd need an air hole is the same thing. Like if I take a cup and I put a little water on the table and I put the cup down on top of that water, and then I try to pull up, it's going to create a vacuum and a suction in there, right? And that is called cupping. That will, if you have large cups, it will yank it right off the build platform. If you have smaller cups, it can cause blowouts and other printing issues. And the solution of that is, if in that cup or that little air gap that might be caused from the surface tension of the resin, if you put a small hole in a place, like oftentimes when I make little robots I'll put a hole right in the middle of their pupil of their eyes, so that those are the air holes and they're in a place that it doesn't matter. But you will need to put an air hole in any of those cups that you can't resolve by orientation. And again, that needs to be 0.8 millimeters down. So that's drainage holes and vent and air holes and what cupping is. So the next one I want to talk about is flagging and scooping. These are two terms that are mine. I've never seen them talked about in the printing thing, but we had a person who was printing in black resin, which takes a lot more like power to solidify. And they were printing something long, like basically the similar size of like an iPhone, in multiples all the way across the build platform. They were printing out 12 of them. And what happens is, remember when we watched the video of the tank actually moves back and forth? What that does is it causes the resin to build up on your part. So when I talk about flagging, what I mean is that I have this big flat piece that's supported up here, but maybe not supported down here. And every time the tank moves back and forth, it puts pressure on it, and the resin comes and builds up against it, and it wants to push it like that. Right? Yet your part is that. However, if your part actually, starts bending, well, what happens? Well, now my part is bending and moving. The laser comes in and starts printing where it was, not where it is, and then it creates a part of unsupported thing called a minima. And then that ends up being, it floats off and creates something we call oatmeal tank, where your tank looks like oatmeal after the end. It's just this mushy, gooey, tons of semi-solidified resin, and you need to then filter the whole tank. And if that happens and we have to filter it, there are some fees, which we'll talk about, which is pretty nasty. So we don't want that to happen. So I call it flagging because it's just like a flag in the wind. Think about it. What you want to do is you want to set the flag so that the air goes by and it flaps nice in the wind, right? However, don't hold your flag against the wind where the wind is catching and it becomes like this sail, right? The same thing for your parts. And what happens, you want it to be parallel to the way that the tank moves back and forth, so that the resin and the tank end up moving back and forth here on your part, and it doesn't cause that flagging. Scooping is a similar thing where if you have like a scoop-shaped part that you didn't want to make a cup so that that cup isn't upside down, it's actually made like a scoop or a cup on its side. What happens is the resin goes inside and starts filling up and putting a lot of pressure or weight and everything else on your part. And then you can cause like resin to be splashed out of the tank basically, or your part starts moving much like that. And so both of those can be fixed just by orienting them so that they are correct. Where scooping, you don't want parallel to the way the build platform moves back and forth. You want it a little askew. Where flagging, you do want that to that. So the next thing I want to talk about is wavy planes. What happens is if you put your part on your thing and any flat planes of your part are parallel to the flat plane of the build platform, what ends up happening is that as the build platform comes down, everything moves, the wiper moves the resin away, and then everything comes back in and it starts lasering again. If you have a big flat plane or even smaller flat planes and the resin is moving through the part as the laser happens, that pressure of the resin moving through kind of like causes the whole thing to be that. The other part of it is that a big flat plane, the laser is trying to hit a lot of space at the same time, and that's what the problem. The solution to that is any flat planes you have on your part, you should tilt just a few degrees, because then that plane will be printed in several layers, and then it won't be trying to print the whole layer at the same time. So if your entire flat plane is in one layer, you're going to have wavy planes. If it's tilted just even a little bit, then you multiply the amount of planes of layers that has, and it becomes out a much nicer print. So there. We talked about tolerances here on there. The workflow of our part. So basically, you're going to take a CAD model, which you're going to either get from Fusion 360 or SolidWorks or Onshape or any of the CAD programs, multitude out there that are out there. And then you export it from your CAD program to an STL or an OBJ. If you go to Thingiverse.com, you could actually grab an STL or OBJ automatically, or you can sometimes grab the CAD file, but most likely it's going to be an STL or an OBJ. Those are non-parametric formats, so meaning that often the sizing can get a little weird on that. And in general, when I'll put my print in, it'll either be itsy bitsy tiny or way too big if there's a problem. Usually the scale is correct, but the scale is off by a certain amount. Usually it's either 10 times bigger or 10 times smaller, or it's 25.4 times off. And that one happens when you're doing inches and millimeter problem, because there's 25.4 millimeters in an inch, and that is what that scale caused. So it's either 10 times one way or the other, or 25.5 or 25.4 times the other way. So, and once you get your STL in, you're ready to slice it up and be ready. However, one option I put in here is that if you want to make your part hollow or add drain holes or air holes, you can use Mesh Mixer. I detest the program for everything. I hate it. It's an awful program. However, it's very easy to make hollow parts or take your part and hollow it out, or to add an air hole or a drainage hole very easily, where sometimes the CAD, it's harder on CAD, or you don't want to change your model based to that. You just want to be able to add those things. And then it goes into preform, and preform is the software that the actual Formlabs uses, which we'll be covering here in just a minute, and why I'm doing a screencast rather than a video cast or a video of that. So let's see, there's other stuff you can. That's Mesh Mixer. You can do this stuff. There's a link here I'll put about how to use Mesh Mixer for hollowing and working for STLs in Fusion 360. But let's talk about preform and selecting all of this stuff there. So preform is the actual software that is here for taking your model and putting it on the Formlabs. So basically what we want to do is to drag a model into our print. Sometimes it'll come up and it'll say some loaded models are damaged and need repair. That's often with STLs, and you can usually just do that automatically. And this layer is pretty good. So I have my print here of a little a case, part of a case for a design that I had worked on. So now, as soon as you put your model in, you can see the boundaries of the printer. You can also see the mixer side and the front, meaning the mixer side that's where the little wiper is along there, and the whole part goes back and forth along the front, or I mean rather the tank goes back and forth along the front axes. And this is my part. So now that I've got my part in, it's saying, hey, I got some problems because there's these red things and it needs more support. Well, duh, I haven't had any support yet. Very rarely that you can add no support. There are a couple things that you can do. The first thing that you should probably set up is just your printer setup. If you come over here and click on your printer type, there's all sorts of different printers. They have the Form3 out. There's even the old Fuse, but we are using the Form2 as the form printer. You can go in and add one of our printers once you're on our network. And usually what it'll ask to do is you can, I think, I forget where, but you can actually add managed devices. You can go into managed devices and add the printer to your thing. And usually what it'll ask you to do is ask the IP address. You just go over to the printer, go into the menu, and find the IP address that way, and then that will get you there. Then you choose all of your materials. We're going to start today with a clear V4, and I'm going to use Brave Hatchling as that. So we have Swift Lamb and Brave Hatchling. I don't know who's Alert Ostrich. I think that's somebody, an old one that has not been used for a while. And there's my job setup. And the main thing is also for your job name, put your name and your phone number so that is as you're printing, if there's ever a problem, someone can contact you about your printer for your job name. Okay, the other part is layer thickness that you want to choose. So there are 3 layer thicknesses with this particular resin. In general, 100 microns is the best to use. If you really need it to be very fine, like I'm doing, I think see if I can find this on my desk here. I printed a little thing in. Let's see if I can get this in front of the video here. It's not gonna focus on my hand here. But this little thing right here is what I was printing, and it's like basically national pipe threading there. It would go into a coupler, and then I could put something on it and use a bike pump to add pressure to test a pressure sensor. Then, of course, it has all of these threads in there, which you really can't see in this camera very well, mainly because my face is in the way. Let's see if I move that. If it actually, yeah, there we go. But you can see really nice threads right there. So those threads, I did at 0.05 millimeters or 50 microns, and that was fine. You almost never need 25 micron layer height. It takes like 10 times longer. Even if you're doing mold making or mold and casting stuff, I found that most of the people who were doing that, they tried the 25 micron. It was just like it took too long, and there wasn't that much improved resolution over the 50 micron. So, but again, most of the time I just do the 100 micron. And then you apply, and now we're ready to be able to start our model and be able to, let's see if the computer actually, while I'm videoing and doing this, which is a graphics program, see if it catches up with me. Okay, there we go. And it will give you some details, time estimate, layers, volume, printability, showing the minima, which is those little islands, and showing the cups, which are problems. So all of those things are issues that can look at. And notice it gives me a printability fail because there's no support. So now we have to choose, like, how do we support this part? And so this part, we're going to support it with is basically, you could start off with just like, if you have no idea where to start, you can click this one print and it will do all of the things for you, orientation and support, and then it'll go right to the printer. And I never go right to the printer, but it can give me a good idea of, like, what does the computer think? In general, the computer always thinks it should be on a 45 and supported liberally. That's great. It's fine. Of course, you can change the size, you can rotate it, you can right click and duplicate it, and do also, or mirror it and do all of those things, or copy it and create more of the same parts if you need to on the same part. Where you're going to spend most of your time here is in the supports dialog. And now with the supports dialog, there are quite a few different things going on here. And so we want to talk a little bit about what each of those are, and then we're going to start generating and editing some support. There are a bunch of rafts. There's full rafts and mini rafts. I don't recommend the mini rafts. They tend to, they're kind of cool, but they're a big cleanup, and particularly they can cause some failed prints. So as much as you save some resin with them, I don't think there's that much of a value for mini rafts, except for really small parts. The full raft is basically what it sounds like. It's a raft that the whole thing is built on. And then, of course, there's none, which in some cases you can print directly to the build platform if you have a big flat surface, and that can be good. Don't do it if you need a lot of dimensional accuracy, though, on that side, because it shrinks all of the layers wherever it's connected. There are some, like, you can do some Z compression correction and play around that, but it's going to take a lot. And if you really need dimensional accuracy, you're going to have to be printing a lot to figure out how to get there. If you need to take the print off, if you build on the platform, there's a really cool trick where if you take these, like the snippers, because they are like a little V that come together, if you put it just basically the flat edge right against the build platform and then snip underneath the edge of the part, it'll just pop right off. And that's how you can get rid of the parts that are adhered to the build platform. You can do that with rafts and everything else too, or you'll just use the scraper that's supplied. So raft label is just if you want it labeled on the raft there, like if you're working with clients or multiple parts or versions or anything else, you can label those. Density, of course, is how close the supports are. Touch point size, right? In general, like 6.6 millimeters is pretty large. And you can go down, but notice it starts giving you errors right after 0.45 millimeter, 0.45 millimeter. And at 0.35 millimeters is kind of as small as you can go before they say, stop doing that. And then you shouldn't use really small budget. They're just not strong enough to hold the part, so that's not worth doing too small. You can do tiny touch points for different places, but you can combine them too. But in this spot, if I just auto generate, it's going to generate them on there. So internal supports. Now, internal supports, these are what basically are supports that go from one part of internal part to another part of the part, not meaning just the parts inside. Like I could have a part going from the build platform all the way up to this part up here, that would not be considered an internal support because it's touching the build plate. Internal support would be as if I'm touching the, if I'm touching here and then, or the little support is touching from in this ledge to that surface. That would be an internal support where it only goes to those things. And so that might be useful, or you may not want them, and you can check that there. The other stuff, flat spacing, you can't change. Slope multiplier, the idea is that if you have a really tight slope and the same density for touch points, it's only going to put a couple or a few on there based on your density, where you can increase that so that only on slopes it's much more dense. And that's a very useful feature, and it's often useful. Height above raft, it makes sense. It's how far your part is above the raft. Raft thickness, you can lower, change that a little bit. And then there's some other things too that you can sometimes play with depending on it there. And so usually what I'll do is I get my part and I say, this is my part. How do I want this printed? Auto print will always put it on an angle. For this part, I think that I'm going to just do it at a little bit of an angle, again, because I have some flat surfaces. And I might make it long like this so that I have the least amount of support. It'll take longer to print, but it's probably going to have better support and finish there. And then I click my auto-generated supports. And so this may take a second since my computer is running both the video software as well as the actual Formlabs, which is a graphics program. Plus I probably have a few too many tabs open in other windows here, which I'm trying to get rid of here. Let's get rid of that. Let's actually just get rid of all those. Let's close. Okay, so generating support. This is taking just a touch longer than it normally does with that, just because I'm running a video and everything on my laptop. And so there, generate support, and there. Okay, so now it's generated its support, and what we want to do is look at how well did it do? Well, I'm making a case, so I really want this to have a good surface finish. Oh, something's frozen here. Let's see. Okay, there we go. Let's actually close this out. There we go. Okay, one more tab looked like it did its good. Let me see if I can quit my other software real quick. Because we're dragging here. As this video gets longer, the video quality. Hey, it's one take for safety. We're doing this one take. You're getting my raw and honest view of all this. So I want this to be nice. So I don't want support here. I want support all on the inside of my actual part. And this so far does good. The other one I want to be careful of is like, where are the support on this tab? Like, that's going to be a problem because it's going to push in and it's not going to cause this tab to close very well. So I want to be careful of that, and I'm going to go edit that later. But overall, this is a pretty good support for my part, and it says it's printable. In general, as long as it's printable, it'll usually work. I tend to be a little conservative with that, but because I also know I have to clean up after the machines, and if there's a resin apocalypse, which we'll talk about later, you don't want that. So the support looks pretty good, but what I'll usually almost always do is go in and edit it. So once I get to edit it, there's this slider here, which actually shows me what all the layers are that are happening from when it gets built from the bottom all the way up. When you're in a different platform, or a different window, it does this the opposite way. But I can see where all my support clicks are right here. So this is an important thing to think about. Like, this is where all my support is and what's okay and what's not okay of what I want to look at. Like, so for example, we talked about right here. That is a bad place for support. I know it needs support, But what I want to do is get rid of it. And then I want to, at 0.45 millimeters, I really want to click right there. And that way it's not right on that edge. It doesn't, I could sand that off pretty easily right there. And the same thing goes with this one. I'm probably going to bring it as much close to the line as I can. And now I've just repaired those parts. And now it's calculating my model for printability. Of course, I should probably do the same on the other side, but for effects of that. Now it says my printability is fast. Doesn't look like there's any red spots that are errors that are problematic on there. And I could go in, obviously I would change a couple more of these. Maybe I don't want so many of these. I could add a couple big touch points rather than so many little touch points. I also might want to say, hey, I want to get rid of this off the edge and put it like basically right there so it doesn't go on two edges. I find these touch points that are right on a corner usually suck. So so those are the ways that I'm going to actually think about with my support and adding that support and where it's going. So now that it's applied, I click apply and it's going to edit my supports, which aren't too different, so it shouldn't take that long. And now I'm ready to actually be able to print and my model is supported and everything looks okay. Do we want to, I do want to think about scooping here because this scooping is might be a problem. So how am I with scooping? Not that bad, but because of this forward, what I am going to do is I am going to shift the whole thing like this. There. And then just in general, I like to put my part away from the center because everybody prints on the center and then the center gets clouded and I don't want to print on it anymore. So, or it gets, the details get fuzzy on there. So this print is pretty much ready to print. And now I'm going to go ahead and simply close that out and say, okay, I'm ready. Let's print this sucker. I go click my print and obviously it's telling me that the printer I'm using has clear in it, but it's missing its cartridge. I've got my job name in there and then I can upload job. So that's when I'm going to be able to go and upload my part and go over to it, and we'll continue the video with a live section of actually on the part on the machine. So the other couple things I wanted to just talk about are on our wiki at wiki.circuitlaunch.com under tools and equipment and the Form Labs. There's a couple informational things that we can do. Let's see if I can make this a little bit bigger so that you can see it and actually read it. There we go. So Circuit Launch right now, again, this is the video of the day. Things all may change, but we'll come back and edit it if they drastically change, but pricing may be a little bit different. Right now, it's 40 cents a milliliters per resin. If you use the Circuit Launch resin, once the print's complete, you send your total amount you used, including if you had a print failed, and you can approximate how much of the resin the print went through, you still are owed for that resin. And it's 40 cents a milliliter. Just put resin in the subject line, email us, and we'll charge your account for that. You can use your own resin and tank. You don't need to, we won't charge you for that. However, you do still need to reserve it on the machine. So again, like with all of our machines, you need to reserve your time on the machine. The other part is you should reserve 30% longer than it suggests. So for example, on my part, it needs 5 hours and 30 minutes. So I need to basically take my calculator and say, because I'm bad at math, so 5.5 times 1.35. So add 35%. So I should book this for 7.5 hours. Even though my print says 5 hours, 30 minutes, 7.5 hours is what I printed, okay? That is because this lies. It lies so bad. I don't know. And the worst thing is that if your print takes longer than it should, someone else makes a reservation and yours is still printing, they just have to sit there and twiddle their thumbs until it's done. I'd much rather you put 7 hours, 7.5 hours on a 5 hour print, and the person comes in and they're like, okay, well, I'm in after them. Their print is done. I can start early. That's not a problem. Or instead of being like, I'm coming in, I booked this time, and now I have to wait who knows how long, it could be many hours before that happens. So that's an important policy part of the print. Cleanup policy. Oh man, I will probably talk to the death of just how messy and disgusting this printer is. This is just not, please leave it cleaner than you found it. And this isn't, you have to clean up other people's messes. I get it. But you have to clean up, even if it's not your mess. If there is more than a reasonable amount of mess that you don't want to be comfortable cleaning up, please put it in, tell us it's broken, hashtag tell us it's broken in the Slack channel, and then we can find out who the last person was. If you don't tell us it was a mess when you come use it, we'll assume that it's you, and you may even be charged for it. If we can't do it. So that's the point. If it's messier than you're willing to clean up, then either clean it up or tell us it's broken in Slack channel so that we can follow this up, right? I'll talk about cleaning in the video part, but you need to make sure you clean all the tools and the handles, right? The other part is that you need to clean the black cleaning station around the container and the lids and everything. You need to clean the isopropyl cleaning bottles, the drip pan below this cleaning area, any drips on the desk, cart, floor, any of those things. And then, of course, report any of these things if they're out or low in stock back to our Slack channel. So you can see a picture here of the closest clean possible. Like there's some dirty on there, it's fine, but they've all been, that's just dried resin. Again, all of the pans are clean. The tools need to be cleaned. The handles are not full of resin. FYI, this is a big no-no right here. This is an electronics tool. Well, I won't say it's a big no-no because we have one specifically for the resin thing that is meant for clipping resin, and if it's there, that's fine. It's actually clipped now to the table, so you can't walk away with it. But don't go grabbing electronics clippers or snippers or needle nose pliers or anything and use that on the resin. Please just don't do it. We have tools there specifically for resin, and so keep it clean. If there's surfaces on any of the resin, please snap a picture, email, Slack it to us. If you don't clean up or report it, it'll be assumed you're a mess. Messes. We don't have a lot of punitive stuff, but first time is a warning. Second time is a stern warning. Third time, we're going to charge you $25 every time you leave a mess. We're not your mom. You got to clean up, and this is messy. And in fact, when you use isopropyl, it basically dissolves all the resin, and then it looks wet. And you wipe it and it looks clean, but in fact, what happens, the isopropyl evaporates and there's still some resin there. So you actually do have to be liberal with the isopropyl and then wipe it all down and clean it up properly. So if we charge you a lot of times, we might put you in, membership in jeopardy. There's also a link right here if you want to use the form wash, which we have, which is automatically, and there's actually how to do that. It's a pretty simple thing instead of how you just put it in and it washes it for you. And we'll talk about it in the video a little bit later there. Let's see, the one part I want to talk about, and I hope I don't repeat myself since I am I did this video, the in-person video first and did all the screencasts, and then I lost my sound on it. So I'm doing this part later. I know it's one take, but this is my second take because I didn't have any sound with the first take. Sorry, guys. Basically there's two things that can cause a fee as well. That is let's see, we've got setup. I've talked about that pretty much. Always wear safety glasses and gloves. Post-processing, policies, maintenance, add 35% more time. Fill a name and phone number for your file name, the cost of printing I did, You must be here for a minimum of 2 hours of your print or a third of the total print time, which is ever's greater when you start off. Eventually, once you have some success with this, then you don't have to do that. But in general, it's a good idea for the first few prints. And we're always happy if you want to ask us questions. Send us your already supported print model, and we can give you a suggestion if it will print well. I want to talk about resin, like oatmeal tank and resin apocalypse. So if you cause a resin apocalypse, that is when your part breaks off and is in the tank, and then the wiper comes and just whooshes resin using your part as a ramp over the side. The resin gets down into the machine, on the optics, onto the lens, onto the laser, inside, and cures and doesn't get, like, it is a nightmare. It's like a 5-hour job to clean up for a resin apocalypse. If you do that, the very first resin apocalypse we ever have is going to be $50. If by the time you watch this video and a resin apocalypse has happened, which hasn't in like the 4 years we've been here, we'll raise the rate. But right now it's going to be $50. If you cause oatmeal tank, meaning your print fails and all of a sudden the tank has a bunch of like stuff floating around in it, we have to pour it through a resin, like a paint strainer, and get all of that out and put it out. And that takes us some time and some staff because you have to do it with 2 people because of pouring and everything. So we're going to charge you $25 if that happens. The only other thing is don't use the acrylic. Use the acrylic cleaner on the orange cover. No isopropyl. So those are our policies. Let's go over to the machine and show you what's going on and how to set it up and do some prints. And we'll be able to do that, and you'll get to see some other people do it too. So cool. And oh. Okay, so this is our 3D printer. This is our Resin Printer Station over here. And the first thing you want to come up to and see is just how clean is everything. So the first part that I'm going to notice is I have someone who did not clean off their tools. That is resin that's clean, that's not there. We do have a policy that if, the first time you'll get a warning, the second time you'll get a stern warning, and the third time we'll actually charge you if you don't clean up your stuff because this gets so messy.
And you have the fingerprint too.
Yes. That's fine. I don't actually know whose plate that is. That's okay. But overall, this actually is very clean. It's just that tool. You have isopropyl alcohol here to deal with. The tray and the tanks for cleaning, all of this stuff is left really nicely. And this is the way you should leave it. The only thing that I saw right at the first is this scraper needs to make sure that I take some isopropyl and wipe it off, right? So you're gonna come over to our printers, and what each of you guys are going to do is actually change out the tank. So, because most of the time you're gonna come and you'll have someone else's part on that. So you'll need to change both the tank and the resin and everything else on that. So, I've got 2 machines, and so what we're gonna end up doing is actually swapping these so that 2 of you guys can do it at the same time. But to show you some of the process at start, the very first thing we wanna do is to remove this build platform right here. This is the platform. It comes off very simply with the lever like that, and it pulls straight off just like that. This one was left nice and clean, looks good. Don't worry about all those scratches. They don't tend to have any issue on your adhesion and problem. So, and then you can just put it face up on the table and set. Now, the next step is I want to disconnect the wiper. So this wiper right here, it just pulls forward towards you, just like that, okay? And to put it back in, you're going to actually place it down and in, and then forward. This is the part where you need to take special attention. Make sure that wiper is always firmly connected when you're ready to start your print, because that can cause a big problem. So the next step to take this thing off will be to take the resin, the wiper off, and just leave it hanging on the tank right there. Okay. Now I'm gonna have to ask someone to hold the phone here. So when you're ready to print, you're gonna come up to your machine. Your print should actually just be right there on the machine if everything is set. If not, you can look at which people's prints are in there, and then I can click on my print and it goes back to there. When I'm ready to print, I'll click print now, and then it's gonna tell me to open the cartridge vent, which is that little vent. Be sure to close that when you're done printing, okay? It's just a little bit of air gets in there. It's not the worst thing in the world, but it's nice to keep the resin pressure there. So that lets the air into the resin, and then it's going to automatically fill your tank in there from the bottom. And so then it's also saying check the build platform. That means checking to make sure that it's clean and ready to go, that there is nothing, you don't have a part left on there. This one is very messy because it just went down into the resin, but that's fine, it should be okay. And then I'm ready to print. I would just actually click my print confirm, and then it'll start printing. Okay. So what we're gonna do is go ahead, what I want you to mainly focus on is my hands here. So this is the tank right here. The way to take the tank out is you want to rest the palms of your hands on the front of the machine there, and then I'm going to just pull on this tab right here forward, and that releases it. Then when I'm ready to pick up the tank, I want to be very careful. You do not want to touch the underside of the tank because that's a clear space. The laser has to go through that. I don't like cleaning that. I hate finding fingerprints there. It's really bad. So there's right here. Notice there is a ridge right along there. Don't put your fingers all the way under, just on the bottom side of this ridge there. And then don't stick your fingers in the tank. And lift it up and out, and then you can place it down on there. Okay, so the one important part is that we have removed the build platform first. Don't leave the build platform on and take the tank out first, because if there's anything that drips from the build platform onto the glass, then it'll cause problems. So let's look at how our glass looks. It's not bad. It could probably use a little bit of cleaning. It shows up worse in the camera than it does actually on the part. But overall, it's pretty good. There's no clouding. There's no fingerprints on that. And then on the tank, we can hold the camera again. There you go. You can see on the bottom here, there's a clear window right there. Well, we'll do this on the clear as well, and you can see through that button, but that's where the resin actually goes. So then, if you will keep videoing for me, I'm gonna put a new tank in, whatever tank I'm using, and I'm gonna put it in, and it kind of goes into the little holes right there. You see there's little square holes. There are feet on the bottom there. Those are gonna go, I'm gonna find those till it drops, and then again, I'm just going to push forward. The reason that I put my palms on there was because it kind of snaps back, and you just want to, you don't want it coming on you. Putting it in, it's fine. Just push it in and push it all the way back and give it a little tug. Then I'm going to put this guy back in. Again, there's a little hole there that you can see up a little bit. Yeah, right there. And that is where this goes. You can see there's a little tab right there, and that tab goes into the hole and pushes forward. And then you can move it while it's connected, it's fine. And then I push it over to the side. Then I'm gonna take my my build platform, slide that on, and bring down the lever, like that. And then I'm going to take my sticky fingers and just use the backs of my palms to kind of close this so I don't get sticky prints all over there. And that's how you change out the tank and the build platform. And now each of us are going to actually do that step and get some practice at it.
For now.
Just always start with the platform first. Yep. Upside down.
Yep.
Squeegee.
Yep, then you take the wiper, disconnect the wiper. Put it to the side. Yep. And then brace your palms, pull back until it snaps back a little bit. Yep. Yours already did that, yep. And then you pull it off, put it on the table.
Mine feels caught on something and I don't want to pull harder on it.
Yeah, what about your wiper? Is your wiper? Oh, the other part is if it gets caught, sometimes
Oh, thank you.
that moves. There you go. That's
Should
a
we
good one.
switch?
Yep, and be careful of your fingers under there. You see how your fingers are in there? You want that to be really, only hold the platform.
Got it.
Okay, and then just put it on the table. Right there. Okay, and then we're gonna do a switcheroo. So go ahead and pick up your thing. Again, 4 fingers right on that platform right there.
Just
and
switch
then
them
why don't you come behind right there? Yep. And then go ahead and put that in. And make sure that it's in and pushed all the way forward before you click the resin tank. So. And if you want to check that it's in, give it a slide left and right, both the resin tank and and you can feel it against the motors and everything else. So it looks good. One tip is if you get a resin sensor error, sometimes you can resolve it just by simply unscooting it or pushing it on one side a little bit. So let's see how we did. There's the resin sensor. It's all the way, the level sensor is there. There's a couple other ones too. Yours looks good. Awesome. They look nice. And now put your build platform back on. And close it using the palms of your hands, not your sticky fingers. There we go. And now reach back and grab the tank. Oh, sorry, the cartridge is the correct term. Out of your, close it, lift that up. And now switch, bar go behind. There you go. Put it in and then open up the cartridge thing. There it is. And so now you've just both successfully switched the resins for your prints. And when you're ready to print, you would just simply click on the button, print now, and you're ready to go. Okay, so now you are ready to take your part off the machine, right? You've switched it out. Basically, you're going to take your build platform off. If I could have another camera person here. I'm gonna take the build platform off, and you can see I've got all sorts of resin on there. I would technically have a part on there. What I'm gonna do is to pull over and grab my resin. Oh, I'm already in trouble because someone left it messy. What do I have to do? I have to take a little bit of paper towel. I probably should put on some gloves to do this. This will be...
I can do that if you want.
You can also do it right here. It's on there. And clean off with a little bit of isopropyl. And then that's good because even if I spill isopropyl, that helps me clean my spots, everything else. So be liberal with your isopropyl. There we go. Now my part is clean. I'll just keep that there for further cleaning. Once you take your part off, what we're going to do is just take any of the resin and just any extra resin and just put it back in.
Then how do you know that you have no pieces that are going to fall? That you can see that?
Well, if your print did a print, so the question is how do you know that there's not little pieces that are there?
Yeah.
You'll see that for the most part, but in general, if you have a successful print, there shouldn't be any parts that are not cured, that are not supported, right? So there, I've cleaned off all my resin and put any extra resin back into the tank. Now what I'm going to do is come over here, and you can do it into the cleaning station or into the isopropyl bath right there. And so we can open the isopropyl bath. Come around so you can see what that little thing looks like. And then what I'm going to do is basically just put my scraper underneath the edge of the print and pop it off into my bath. Then once I've gotten that off, I can then put this down, change anything I need it, or I can put it back. But remember, don't put this back over an empty glass there. The tank has to be in before you put this over, so otherwise there's a little bit. And if it looks like this, we also need to clean it. So I'm going to take a little bit of isopropyl, spray it on, and wipe it off. There we go. And so now this part can then come back in here and clip back in, and I'm set. Now I can deal with my actual part in my wash. Now the recommended wash is that you do a minute of agitation and then 5 minutes sitting in isopropyl, and then move to another cleaner bath and do another 5 minutes, right? We also have the wonderful, we have two different this is the bath here, which is super easy to use. You just simply, this says how long am I going to do this wash, and I say I'm going to do a wash for 10 minutes, and then click open, and then you can put your part in there, and then you just click start, and it'll wash it all for you. This is really nice.
It's ultrasound?
No, it's just heated. I think it's not even heated. I think it's just isopropyl, and it agitates it.
Okay.
Yeah, but it does timing, and it does all that for you. So then I'm ready to say sleep, and it will go in and clear that out for you. So there is a UV curing station right here. For the clear and the gray, you don't generally need to do curing. For other resins, you may, and you can go ahead and just look at how long you need to put it in. It's a pretty simple process. So, but that's how you take your part off and how you are there. And then the most important part is once you've actually taken your part off, you make sure that I left my resin on here. So I'm going to spray. I'm going to be liberal. I'll be like, oops, I've sprayed it all over the place. That's fine. And then I wipe everything down. And the one thing to note, when the isopropyl hits this stuff, right, it is great. It looks clean. It's wet, but it has dissolved resin still in it. So when it evaporates, it's going to leave the resin that you think is gone just because it's wet right where it is. So do take the time to actually wipe all of that down, not just wet it. And then make sure your tools, the handles of your tools are all cleaned off. And don't be like me, wear gloves. Okay. If you do leave fingerprints, or you would like to help us keep things clean too, again, remember, don't use isopropyl on the acrylic. Use this stuff. It's Novus Plastic Clean and Shine. You can spray here. Tonight, you want to give me a little? You can just spray a little on here or on there, or on the towel. You can do this too, and go ahead and just give that a little wipe. This is a great way to just kind of get it clean. It'll never. I mean, this stuff is so messy. It'll never get super clean, but it'll take off what's not cured. So. Yep, there we go.